Alright, so calculus is often split up into two main parts, you could say, which are differentiation and integration. Typically, people look at differentiation first, so let's do that. So, differentiation. But what does this really mean? So let's look at an example. So let's consider you're going by bike, you're riding your bike and you're going 10 kilometers. So you're riding 10 kilometers, and let's suppose it takes you about 30 minutes to do this. And so now the question becomes, well, how fast did you ride? Well, one could say, okay, 10 kilometers in 30 minutes. So that means in 6 minutes we go 20 kilometers, which means this was 20 kilometers per hour. So far, so good. Well, this would only be the average of what you went in these 30 minutes, right? This would only be the average velocity. And we want to be more precise than that. So, for example, if you go by bike and you know this yourself, right? You wouldn't go perfectly 20 kilometers per hour the whole 30 minutes. You would slow down every now and then because there's a traffic light or because there's a hill, and then you go uphill, you have to go a bit slower, downhill a bit faster. So if we put this on a graph, it would look something like this, right? So the x-axis here is time and the y-axis here is distance covered. So this is where you arrive at your final 10 kilometer point, and this is your 30 minutes. So you start at 0 obviously, and you go all the way up to about here. So if you went at 20 kilometers per hour, perfectly straight, perfectly even pace the whole way, the graph would look something like this, right? It would be a straight line. No, that's not perfect, but you get the point. It would just be a straight line. However, like I just said, in real life, you wouldn't be going perfectly smooth. So you'd be faster at times, you'd be slower at times. So the graph is more likely to look something like this, maybe. So now you think, oh well, so how fast do we go there? Well, on average, you still went 20 kilometers per hour. But how fast did you go at this point? Or how fast did you go at that point? Or this point? Well, that's where differentiation comes in. So differentiation takes the equation of this curve, of this curve that represents your cycling in this scenario, and it differentiates it. Well, it applies this method to which we're going to learn, and in a graphical sense, it finds its slope, because velocity, right, or the speed in this case, let's not make this a vector, but the speed is distance over time, right? So that's the y component, so the change in y over the change in x, which is your slope of the graph. So for straight lines, obviously that is very easy to do, but for a curved graph or something like what I've shown here, that's a bit harder to do for a quadratic or any sort of polynomial. So that's where calculus comes in. So calculus allows us to calculate the slope of a graph, the incline at any given point, and even more so, you can find an equation for the slope of the graph, not just absolute numbers. You will find an equation. So from the equation for your distance, so from the equation for distance in this case, you can then find the equation for speed, and that is done through differentiation. And this can be used obviously in many different real life scenarios. It doesn't have to be distance over time and giving speed. You can go further and then graph the speed, and then from that find acceleration. Or it can be used in many different scenarios in physics and just really any place where variables kind of relate through the slope of a graph. So we're going to look into that, but that for now is kind of a brief overview of what differentiation is, and then kind of what it really means in a real life sense rather than just the mathematical sense.